All right, you guys, so this is page 4 of the study guide, and to be honest with you, the first question is reasonably capable of you guys doing. The second question I'm going to do for you guys, but the reality is it's a little bit more difficult, and I don't think that's going to be something that we're going to see on the test, okay? So the first one, it just talks about that we're moving up this elevator at a constant speed. If we're moving at a constant speed, that must mean that there's no net force, and so the normal force has to equal the force of gravity. That's the hardest part, right? If we're moving at a constant speed, then this arrow has to be the same size as this arrow. And so now this just becomes very simple. Find the force of gravity, which is mass times gravity, or F of g is equal to 68 times negative 9.8. Right? And 68 kilograms times 9.8 is 6664. Kind of an unlucky number there. All right, and since the force of gravity equals the force normal, then the force normal has to be 666.4 newtons up. Okay, that's doable. You just have to go through the stuff that we've taught you guys. The next one is a little bit more difficult because now the elevator is accelerating down. If we just think about it, that must mean that the force down has to be much higher than the force up. Right? This arrow must be longer than this arrow. Right? So that's the free body diagram. And it says, write an equation for the net force. Well, this is pretty simple. The net force is equal to the Fn minus Fg. Now, in Miss Moise's class, they must be using down as positive and up as negative. In my class, we do the opposite. So it doesn't really matter. You're just going to take whatever one side minus the other side will get you F net. Okay? It all depends on how you define it. Now, here's the problem where it gets difficult. The object is accelerating. So if we look at this, the F net, we don't know. All right? But we do know the acceleration is 1.8. And we do know the mass is 30, right? Oh, 68. Mass is 68. So we can find F net is just mass times acceleration, or F net is equal to 68 times 1.8. All right? And then 68 times 1.8 is 122.4. That's F net. But what's the equation for F net? Well, we said F net is equal to the normal force minus the force of gravity. And so F net is equal to, or I'm sorry, 122.4 is equal to what? Well, the force normal. The force normal is what we don't know, minus the force of gravity. Well, the force of gravity is way up here, 664. .4. And so we can solve for the force normal. Okay, but the only problem is that we need to remember that when, and at least in my class, right, that this is a negative acceleration, so this is a negative number. And so when we add 664 here to this side, plus 666.4, plus 666.4, we'll get F normal equals whatever that is right there. And I think it's 544 newtons. Okay? It'll be much cleaner on the key when I put that together, you guys. All right, we're on this side. Remember, we did this stuff, and whenever we did this, remember we just simply draw a line between the two objects, right? And they're asking us for what's the reaction force. So if the ball hits the bat forward, remember we just switch these words. Ball hits bat backwards. Okay, you're just doing the same thing. So if the person pushes the car pushes the person. So man pushes car to the right, right? Car pushes man to the left. Okay, equal and opposite. All right, force, the bus hits a bug. So here's the bug, right? Bus hits bug, bug hits bus. Bus hits bug, bug hits bus. Not difficult at all if we remember to draw our line there, okay? All right, they ask us now to draw this free body diagram of this person at a angle. Okay, so the force must be going this way, so the applied force must be going this way. They tell us that it's going to be speeding up, so that must mean that the force of friction has to be less than that. Right? Gravity always goes down, force of gravity, and the normal force is always perpendicular to the objects holding it. So that's the free body diagram of that. And they're all not very equal. Okay, so there's no equal sides anywhere. All right, the next question talks about a box sliding on a level floor. The person is pushing forward with a 190 Newton force to the right, but the friction of the floor is pushing with 190 to the left. With the information, what was going to happen? And this is, remember I told you, physics teachers love to constantly test this, that if the forces are balanced, there's two things that can happen. It's either stopped or it's moving at a constant speed. It will not just stop automatically. It needs a bigger force. So it's going to be moving at a constant speed. Since the forces are balanced, the boxes will keep moving. Okay? All right. Now we get to some of the stuff that you guys were working on in the last section. So this stuff is all about just plugging it into the gravity equation. Right? So if we have a mass, and we have another mass, and we have the distance between them, we just need to be able to put it into the equation. Force is equal to G m1 m2 divided by r squared. Okay, some really big numbers, but remember that you need to use 6.67 times 10 to the negative 11 for G. Right? Sorry, put that over there. And remember then the mass, we put the masses in. And whenever we put in the radius, or the distance between them, in this case 6.67, or 6.7 times 10 to the 5th, we need to square that. All right? So this m right here goes in here. This m right here goes in here. And then we've been working really hard on putting that into our calculator the correct way. So the answer I got for that force of gravity the only problem here is that we gave it to you guys in kilometers. We got to put it in meters. So this is going to be to the 8th right here. Okay, so that if you're wondering why, we will not do this to you on the test where we give you something in kilometers and ask you to change it to meters. Okay, we're just going to give you the right numbers. Okay. All right. Question 19. This is the one where too many of us are making a mistake. If you're in either class, this is the way we do this. Okay. There's two questions here, I think. Well, maybe just one. Okay. We write down the equation. Force equals G m1 m2 divided by r squared. Okay. It says that objects attract each other with a gravitational force of 16. So this is going to be 16. Now we're going to change things around. So I'm going to use this second side right here to figure out what the changes are. They say the mass of both objects was tripled. So F is equal to G 3 times m1, 3 times m2. Okay? And the distance between the objects was doubled. So I have to put 2r and I square it. Now all I'm going to do is look at this and say, what does this mean, right? How does this look? So this does look like this. F is equal to G. 3 times 3 is 9. M1 times M2, right? I just took the 3's, put them together, that's 9. And then I'm going to square 4R, or 2R, that's 4R squared. Okay? So what have I changed? I've got, between this equation and this equation, I've got a 9 divided by a 4. Right? That's the only thing that's difference between this equation and this. So whatever we do to one side, we do to the other. So we must have to multiply 9/4 times 16 to get our number, and I think that's going to be 36. So the new force of gravity is 36. Okay? So remember, write down the equation, write down the new stuff, simplify it. Whatever we do to one side, we have to do to the other side, and that will get us the answer. Okay? And the last stuff you guys can look at, the gravitational force is the force that the Earth provides or some sort of planet provides. The normal force, the force of the ground or a table or something like that. The tension force is the same as the applied force. It's the force caused by a rope. The applied force is anything that's caused by a person or anything that's pulling. Friction force, always opposite of the direction of the motion. And air resistance is basically a friction force. All right. I will clean up this key, and so the key that I post will be a much cleaner one, and you guys can take a look at that. There was a mistake on the first video on question 8, where I used the force instead of the mass, and you'll see that on the key as well.